Assalamualaikum everyone, my name is Mazatu Jamila and I will introduce about differentiations and solve questions for MAT183 video assignment. So let's take a look what is differentiation. Basically, it is a method of finding derivative of a function which represents its instantaneous rate of change. So we have 5 techniques we could use on different questions to differentiate. First we have basic, and second product rule, and quotient rule, chain rule, and implicit. So let me explain about basic derivatives, which is we can take a look at this. This is example. You can do what if you find like this on questions, so you know what you should do. So let's take a look on example. We have fx equal to 10. So how we want to differentiate it? So 10 is a constant value, so we know that when we differentiate it, any constant value is equal to 0. So f prime s equal to 0. Next question B, we want to differentiate x. So if we want to differentiate x, dy dx equal to 1. Why 1? Because we see the value of x is 1. What if the question is y equal to 2x? Then the answer should be dy dx equal to 2, because we take a look at the number in front of x. So that's the value of differentiation. So next question, fx equal to x square. So when we take a look at this, the difference is this one have a power. So when we want to differentiate it, f prime s equal to the power of this bring into the front, and we got 2x and the power minus 1. So we got the answer 2x. Next one, we have y equal to third x. So before that, we want to remove this by y equal to x, the power 1 over 2. Next, we got dy dx equal to this one, we just bring the power to the front, and the power minus by 1. And we got the final answer. Next one, fx equal to 1 over x. So this one, if you want to differentiate it, you look at the power of this. This one is 1. So that's why when you want to differentiate this one, f prime s is equal to x, the power of negative 1. What if the power is fx equal to 1 over x, the power of 2? Then the answer you got is f prime s equal to x, the power of negative 2. Next technique is the product rule. So what is product rule? Basically, it's a method to find differentiation of a function given in the form of two differentiable functions. So let's take a look at example. For product rule, we have a formula which is f prime x equal to u v prime plus v u prime. So let's take a look at example of these questions. We have 2x and in bracket x minus 6 square. So the first value at the front, we call it as a u, and the second value we see is v. So u equal to 2x. Then for u prime, you just differentiate the value of u. So for u, we got 2x. So if we differentiate it, we got 2. So v is equal to x minus 6 square. So we just expand it as usual. And for v prime, we just differentiate it to x square. X square. And 2, we bring it to the front. We got 2x and the power minus by 1, we got 1. And for 12x, we just put 12. So this one is the value for v prime. So for this 4, we just put it at the formula that give. So we got f prime s is equal to 2x times 2x minus 12 and plus. Make sure you put plus, not minus. And plus x square minus 12x plus 36 and times 2. And we expand it. And we got this. And the final answer you got is 6x square plus 40x plus 17.
Alright, next we have a quotient rule. Quotient rule is used when we have a y function divided into another function, which is d over dxu divided by v. So we have a formula for this, which is v times u prime minus u times v prime over v square. So u is our numerator and v is our denominator. For example, we have a y equals to x minus 1 over x square minus 2. So x minus 1 is our u and x square minus 2 is our v. So we can insert it into our formula. So for u and v is given in the equation, right? For u prime, we need to differentiate the u. So we have a u is x minus 1. So if we differentiate x minus 1 is equal to 1. And if we differentiate v, which is for v prime, we need to differentiate v. So v is x squared minus 2. So after we differentiate the x squared minus 2, it turns into equals to 2. So after we get all of the information, we need to insert it into the formula. And after we insert into the formula, we can simplify it and turns into the final answer. Alright, for the next one, we have a chain rule. Chain rule is we use when we have a composite function. Essentially, a function inside another function. For example, we have a 3x in the bracket with a power of 2. So we need to apply the chain rule. But for the last one, we have an implicit differentiation, which is before we have an equation like y equals to u over v, y equals to u times v. But for implicit, it's tangled up together with the y inside the x equation. So for implicit, we differentiate everything from left to the right normally, but with one crucial golden rule. So the rule is, because y is the function of x, so every single time you take the derivative of a term containing y, you must apply the chain rule and multiply it by dy over dx. And for quotient, quotient rule is for a fraction, and chain rule is for the nested function, and implicit differentiation when x and y are stuck together. Alright, next, moving on to the question 2. For the question 2, we've got the equation of y equal to 3x exponential negative 2x plus 5. Alright, so maybe looks like a complicated equation, but if we arrange it by a rule, it may be easier for us. So first, we need to divide it into 2 d dx, which is for some rule. If there's plus between two expression, we need to divide it by d over dx 3x exponential negative 2x plus d over dx 5. Alright, for the y, what should we do for y? Alright, for y, we have d dxy, and we can change it into dy over dx. Alright, d over dx 3x exponential negative 2x. Use a product rule. We learned before for product rule, d over dx u times v, we can use the formula u times v prime plus v times u prime. Alright, so follow the formula given. For u, we can express it as a 3x. And then for u prime, we need to differentiate the u equation, which is 3x. So 3x differentiate into 3. For the v here, we have exponential negative 2x. So for the exponential, the basic we had to know is to differentiate exponential, we need to copy variable times to differentiate power. Alright, so here the variable is exponential negative 2x. So we copy the variable exponential negative 2x times the difference of power. So here the power is negative 2x. So if we differentiate it, it turns into negative 2 only. So after we write all of the information, we insert the information we have into the formula, which is u times v prime plus v times u prime. And after that, alright, that's for the first expression. Alright, for the second expression is a constant. Here we see it is a d over dx constant equals to 0. That's for constant rule. So here we can apply the constant rule at this 5. So d over dx 5 equals to 0. Alright, so we can simplify this expression into negative 6x exponential negative 2x plus 3 exponential negative 2x. So dy over dx equal to 3 exponential negative 2x 1 minus 2x. That's all.
Question 3. Find dy dx of the following equation using implicit differentiation. For question C, y to the power of 3 equals to cosine to the power of 2 to x plus tangent xy. We will differentiate both sides with respect to x since y is defined implicitly in terms of x. Starting from the left side, we use chain rule to solve the derivative of y to the power of 3. This gives us 3 multiply y to the power of 2 multiply dy dx. For the right side, we have two terms. For cosine to the power of 2 to x, we apply the chain rule twice. Outer derivative gives 2 multiplies cosine to x multiplied by the derivative of cosine, which is negative sin to x. And finally, multiply by the derivative of the inner function to x, which is 2. This simplifies to negative 4 cosine to x sine to x. For tangent xy, the derivative of tangent is secant to the power of 2xy. Then we apply the product rule to the inner function xy, giving us x dy dx plus y. This simplifies to secant to the power of 2xy multiply x dy dx plus y. When we combine this, we get 3y to the power of 2 dy dx equals to negative 4 cosine to x sine to x plus x secant to the power of 2xy dy dx plus y secant to the power of 2xy. Next, we remove all terms containing dy dx to the left side and keep the remaining terms on the right. Then we factor out dy dx from the left-hand side. For equation 3y to the power of 2 minus x secant to the power of 2xy, we will move to the right side and change the symbol to the divide. So we can get dy dx equals to negative 4 cosine to x sine to x plus y secant to the power of 2xy divided by 3y to the power of 2 minus x secant to the power of 2xy. For a better answer, we rearrange the equation by lid with a positive terms, which is y secant to the power of 2xy. The final result is dy dx equals to y secant to the power of 2xy negative 4 cosine to x sine to x divided by 3y to the power of 2 minus x secant to the power of 2xy.
Example of question 4 about linear approximation. So, the question is, use linear approximation to estimate the value of the following problems correct to 4 decimal places. So, we have set 169 minus 4.9 square. So, first we need to find the x and x naught value. So, for x, we need to put the decimal value, which is 4.9. We cannot put 169 because it's not in decimal places. So, for x naught, we just round off the x value to get x naught, which is 5. For delta x, we just minus x naught, so we got negative 0.1. And then we need to find fx, which is fx. We can write it as in bracket 169 minus x squared and power 1 over 2. For f prime x, we need to differentiate the fx, which is the power, bring it to the front, and power minus by y. So 1 over 2, and in bracket we just copy this, and we need to differentiate the value inside and put it at the outside. And then you just can write this like this, and make sure to cancel if there's a value that can be cancelled. And we can write it f prime x as negative x over set 169 minus x squared. Next, we can find linear approximation using this formula. So, f x naught, which is the value of x. At here, we need to change it to 5. F prime x, for the x, put the x naught value inside the x, which is, we change the x into 5, like this. And times delta x, which is delta x we get is negative 0.1. So, our final answer is 12.0417. Make sure you round up to 4 decimal places.
the process of finding a derivative, which tells us how a function changes at any point. It is based on the concept of limits and is one of the core ideas in calculus 1. Differentiation helps us understand rates of change, find slopes of curves and tangent lines, solve real-world problems like optimization and motion, mastering techniques like the power rule, the product rule, the quaternion rule, and the chain rule, allow us to analyze and model many different types of functions. That's all from us. Thank you.